Okay, now let's derive the components of the stiffness matrix and load vector using MATLAB symbolic toolbox for linear triangular elements. So you can see the equation for calculation of Mij of element. We should calculate this integral. Here, norm functions are functions of x and y, but we should translate this equation into our standard coordinate system. In the standard coordinate system, n1 is equal 1 minus zeta minus eta, n2 is equal zeta, and n3 is equal to eta. And also, we have these equations for mapping the arbitrary element onto the standard element. So I wrote this M file and I used MATLAB symbolic toolbox. Here you can see variables alpha x, alpha y, eta, zeta, x1, y1, x21, y21, x31, y31, x23, and y23. So here you can see these two equations, 2.70, these two equations, and you know that the Jacobian matrix is equal to this one, this matrix. And here I calculated the Jacobian matrix. Actually, partial derivative of x and y respect to zeta and eta. So using inv function, you can calculate inverse of Jacobian matrix. And here you can see this function. Actually, we need to know the value of partial derivative of norm functions respect to x and y. So I wrote here n, our norm functions are n1 here, n2, and n3. So partial derivative of n respect to x is equal to this expression, and this is partial derivative of y respect to x. Actually, these two lines are this equation. So also, we can calculate determinant of the Jacobian matrix using this function, det of j, right? Using this MATLAB function. So here the aim is calculation of this integral. So this is on arbitrary element, and here is the arbitrary element, as you can see. And this is our reference element, as you know. This is zeta, and this is eta. This is 1, this is 1. So what is this function? The equation of this line. The equation of this line is 1 minus zeta, right? This line. So we have a double integral here. When we change this integral in terms of eta and zeta, we should use this equation. As you know, this equation 2.82. So in this equation, no matter if you want to do integration over zeta first, this is 1 minus eta. But if you want to do integration over eta first, this is 1 minus zeta. And this is from 0 to 1, 0 to 1 minus eta, right? This is a double integral. So I calculated this double integral here. Integral of this expression times determinant of Jacobian matrix, and here are limits, lower limit and our limit. So simply in this number of lines, you can calculate components of the M matrix. For example, M11 is this equation 2.83, and this is M11. X23 squared, Y23 squared, alpha Y, alpha X. This is alpha X, Y23 squared, this one, this term, and this is this term, right? And so on. So you can calculate other terms. I used some functions here to simplify and show these symbolic variables in a pretty form, right? So this is the procedure for calculation of components of the matrix M, T, and F and P using MATLAB symbolic toolbox. So I wrote this M file, and you can use this M file as an example and use it for other formulations, right? Okay, for example, this is Tij, and you can use the symbolic toolbox to calculate components of Tij. So do you have any question about using the symbolic toolbox?
No, this is clear.
Right, right.